This is a segmental bend, also known as lobster back bend, because when we look at the back of it, especially when it's got more segments, it looks like the back of a lobster. It's used to create a bend in a straight tube when we can't bend the tube for whatever reason, usually due to size and thickness, and create a nice flow around like we need it to be. It looks complicated, but once we break it down, it comes down into a simple method. But that method is parallel line method, and we can use that for a lot of problem solving going forward. And once it's broken down, it's simple to understand, and it's a good tool to have in your arsenal for problem solving in the future. Let me show you how I break it down. I started initially by putting centre line in, as you can see. Got the base diameters in, which are constant. There's no particular size what I'm working to. If you are working to a particular size and your internal is a critical size, make this size the internal. If the external is a critical size, makes the external this diameter, this line here. And then from there, all I've done, projected these lines together to create what we can see is a starting point of where it needs to flow. As we can see from the model, that's what we need to do. The next stage is now put it into segments. Segment it quite simply. I'm going to take the radius from the outside diameter and step it off as usual to get us points. I've been getting these three sections. I'm now going to divide these over three sections into segments also. Now it's in sections. The first thing we're going to do is set the ends. I'm going to do this by running the line 90 degrees from the base, up, up, up and across. So these lines have been projected across at 90 degrees. This keeps the ends square, as you can see. So we can then, tubes can go in there nice and square. If it's cutting on an ellipse, it creates a problem when we're coming, joining things together especially. So our starting point is to make the square ends first. Now we've got this, it's quite a simple procedure of joining that to that tangential to these lines here. I'll show you. If you need a fancier look, you could put more bends in there, more segments, but I've just chosen quite a simple one really, just with 4 bends in, just to show the initial development pattern, how it works. Now we've got the full drawing in place. We can see clearly the segments. You can see clearly it matches where it should do. Now we're ready for developing. Now we need to get divisions to create some lines into his development. We do this by creating half a plan length, as usual. We don't need a full plan length because we can just get away with half in this instance. And I'm going to step it out into 6 equal spacings. And now I'm going to project these lines up into this development. Here we have all divided up now. Lines projected up through both developments. These two developments are different. This is essentially a half development. This is half that distance. And this is a full development. I've numbered these 0 on the inside around to 6. The reason for this is I'm using the inside as my joint line. I always choose the smaller side for my joint line and also the inside. So the outside is more visually appealing and there's less work on there. And also there's less welding if we're putting it together on the inside joint than there is obviously on these long outside edges. Some people like to start the developments in the middle and that creates like a fish pattern. I prefer, like I say, to start on the middle, on the inside edge here. So we've drawn this bottom quarter section, half section should I say. That's ready to go. So all we need to do now is draw it, what it looks like in the flat. On jobs like this, accuracy is quite important. So what I've done for this, I've worked out the circumferential length by using the diameter times by pi, and then dividing that by 12. So you get the spacings we've got there. And that will create more accuracy going forward, especially when you use the same constant for the next development also. Once we're at this stage, it's quite a simple parallel line straight across. Projecting these lines, these are all true lengths. So we're just projecting these across like this. This creates a simple grid and it's a simple step up. 0, 0, plus 1. This is a starting point and his end point because that's where his joint is. If it's that side, it's also on this side. And now it's simple, follow these points across to create the shape of our pattern. And there we have a simple pattern which creates the 2 ends required for the segmental bend, or lobster back as we want to call it. Half section sorted. Now onto the full development. For this, I've just projected the centre line out, and I'm going to repeat the process, what we've done here. I'm going to use the same constant length, circumferential length we've worked out, and go along there and mark the 12 steps along the centre line as before. Now we've got a centre line projected out at the same length as this, with the same spacings also. we're now at 90 degrees, pull those lines through to create these lines as we did before. We can, as before, project these lines up parallel to create a grid, but some instances it's a bit difficult, so what I'm going to do in this instance is going to step it off on the true length, and then from there, on each number, draw the length what we require. I'm going to follow this process all the way up, and so on and so forth. All the points are plotted now, all clearly defined. As before, we just need to join all these up to create our full pattern. That is our full pattern now marked out. And when we put the full and the half together, it creates half of the segmental or lobster back bend. All we need to do is replicate that. So we need 2 of these in total, 2 of these in total, and then that should make us model. It's got a fancy name, but as you can see, it's a simple idea. This principle turns up in places that you don't expect. If you can understand how to make one segment, you'll be able to understand how to make the whole bend.